you just verify that you can see my screen and hear me okay?
I can see it perfectly and I can hear you.
Excellent. Well, like Bill said, this is the second webinar in a series of 6, and today we're going to look at how to debug R code with the RStudio IDE. Last week we looked at how to write code, so that's sort of the prerequisite for this. You write your code first and then you debug it. If you want to check out last week's webinar because perhaps you missed it, it is now online, and I'll show you the link where you can look it up on the next slide. This webinar is just the second in a series of 6, and you can see that the webinars to come will focus on other things. One I'm particularly excited about is next week we're going to look at how to write packages with RStudio. And the reason I'm excited about that is because when I meet R users, most of them seem to think that writing packages is just for the most advanced R users out there. But really, a package is the most efficient way to share any functions that you're reusing, code that you're reusing, things that you're already sharing with your coworkers. You can share more efficiently by writing a package, and we'll look at how to do that. The ones that follow after that will start in January of the new year, and we'll look at things that will make you more efficient, help you collaborate, and help you create reproducible research. But today, it's debugging. Once we film all these webinars, we'll go put them up here at this address. So you can always go back and look at the webinars. And the webinar that we filmed last week is already there waiting for you in case you missed it and would like to look at it. All of these webinars will be about 30 minutes long, some of them shorter, some maybe a little longer with questions. So what's our agenda for today? First, we're going to look at how you could debug the functions that you write, and then we'll look at how you can manage errors. Speaking of errors, that last bullet point should be 3. Third thing we're going to look at is how you could use debugging techniques in R Markdown documents and in your Shiny apps. Some useful commands that you might want to know about. These come with R, and they're very useful when you're trying to debug your work, or the debug, unbug, undebug functions. Everything on this slide. I'm going to refer to some of these throughout the webinar because they interact with the RStudio IDE to create a useful debugging experience. But if you want to learn more about any of these because you're not familiar with them, all you need to do is look at the functions help page. Where those last set of options, you look at the options help page. And then finally, the things we're covering today are baked into the IDE. They're not really very new, and we do have documentation on them. So if you want to pursue this further, I welcome you to look at our debugging documentation, which you can find at this link. All right, so let's take a look at the RStudio IDE and how you can use it to debug your work. I'm going to open up a version of the RStudio Server Pro. So here we are. And I've prepared some scripts here. And by prepared, mostly I stole them from other people at RStudio, mainly Jonathan McPherson. I've also stolen some of his jokes, so if you hear a funny joke during the webinar today, that's from him. If you hear a cheesy one, that's probably my own. All right. The first script here is a set of functions, and to make it easier to see, I'm just going to reorganize the panes in my IDE. I'm going to move the console over here where the files pane normally exists. This is something you could do whenever you like. You could put your panes however you please. By doing this, it's going to let me expand the script here, and we can see the whole thing here. Here's the command line where I'd write R code. So what does this script do? This is some code that has to do with the Project Euler question or problem to solve, which is we're trying to find the largest number that you can make as a product of 3-digit numbers. So you multiply 2 3-digit numbers together, whose answer, whose number, is a palindrome. That means the number is the same forward and backwards. So this is vaguely interesting, especially mathematicians, but it's a difficult problem to solve. However, if you can use computer code, you have a fighting chance of doing it. And that's what this code is intended to do. So we have some code here that tests whether a number is a palindrome. And then we have some code down here, biggest palindrome, which is going to search through all the palindromes you can make as a product of 3-digit numbers and find the largest one. This code is not loaded into my R session, it's just an R script. So I'm going to start by sourcing the code by clicking the source button. Now you can immediately see in our environments pane that these 3 functions in the script have been defined. They're here ready for us to use. So let's go ahead and use the biggest palindrome function to see if our code works. Now, if you guess that the code doesn't work on our first shot, then you're right. I mean, this is the palindrome the code returns. You can see that number is not the same forwards or backwards. It's actually quite embarrassing. That's not a palindrome. In fact, that's just the biggest number you can make by multiplying 2 3-digit numbers together. So somewhere in the script, our code has failed. And our job as a debugger is to figure out where that happened. Now, if you are an R user, you're probably familiar with the function debug once. Actually, I take that back. There's no reason you'd be familiar with it. But if you ever debug code in R, you know that the debug once function is a function that you could use to debug any function that you have in R. And it's analogous to debug and undebug. But perhaps I'm getting ahead of myself. Let's take a look and just check maybe the palindrome function to see if that's what we should look at. The error is either in biggest palindrome, or get digit. So we could give palindrome a number like 998001 and see if palindrome tells us that this is in fact a palindrome. It's not a palindrome, so we should get false. We see here we get true. So I'm going to start by trying to debug the palindrome function, and I'm going to use the debug once function on it. The way you use debug once is you call it on the name of a function you want to debug, and then the next time you run that function, RStudio will open the debugger mode to help you examine the function. So let's give palindrome a number that actually is a palindrome. So 123321, forward and backwards, that's the same number. When I run the function, instead of just executing it and giving me back the answer, RStudio has opened a debugger mode. And this is what the debugger mode looks like. You'll know you're in a debugger mode because you have this traceback pane that appears in your environments window. And the console also starts to look a little different. Most noticeably, your command line prompt, instead of being a greater than sign, it says browse to greater than. That means you're inside debugger mode. Now, what is debugger mode? Well, if you've ever seen the movie The Matrix, the debugger mode is very similar to Neo in The Matrix, where if you were Neo, you could stop time, you could rearrange things, you could change the state of your world, and sort of explore things in slow motion. That's what debugger mode offers you as an R user. We've stopped the execution of R right in the middle of the palindrome function. You can see over here in the source window, when you're in debugger mode, that one line in the source window will be highlighted. That's where execution is stopped. So the highlight's kind of small here, it's just on this bracket. But basically R began execute palindrome and it stopped and it gave control back to us. It hasn't run any of the code in palindrome yet, which is good because whatever went wrong has not yet happened. We can sort of investigate and follow along to see what's going to happen. When you're in debugger mode, you could enter commands at the command line just like you would in regular R. So I could do something silly like look up the mean of 1 through 10, and R will tell us that. But the interesting thing about debugger mode is the commands that you execute here, R is going to execute them as if they appeared where the highlighted line is here. So if I ran the mean function from inside palindrome, R will calculate the mean in the dutiful and correct way. But that's not really interesting to me. What's more interesting to me is if I'm right here at the start of the palindrome function, what does the num variable look like? So I could look that up. If I fight against tab completion. The num variable is 1, 2, 3, 3, 2, 1. That's as expected. Now I want to see what palindrome's going to do with that number. Well, let me point out another opportunity we have. Since we're here running commands, we can actually change variables at this point in the process. And this is a great way to test solutions on the fly. For now, let's just change num to a different palindrome. It doesn't really make a difference, but we can see up here in the environment that the value of num is now changed. Palindrome's going to use our new value as it goes through the process. We can advance through palindrome one line at a time by clicking the next button that's appeared in the console. This next continue stop. These only appear when you're in debugger mode. And what next does is it advances the code one line at a time. It will run the next line of code, and we'll see the highlight move down to show us moved that has ran a new line. The highlight shows you the next line of code that will be run. So the next time I click next, R will run digits for log num 10. We can do that. And now we see digits has been defined in our environment. We can see what digits is. In this case, digits is just telling us how many numbers are in num. There's 6 numbers or 6 digits. After we calculate the number of digits in our number, then palindrome is going to use a loop to compare the first digit to the last digit, second digit to the second to last digit, and so on to see if they're the same. So we could go through that loop one line at a time. First, we'll extract the first digit. Then we'll extract the second digit. And then we'll compare those digits to see if they're the same. If they're not the same, palindrome is going to stop immediately and be false. This is not a palindrome. If they are the same after we compare all the digits, it'll return true, saying yes, this is a palindrome. So we could hit next and we could see that it just goes on to the next iteration of the loop. Digit 1, digit 2 were the same. And since we're looking at a palindrome, that makes sense. But if you're sharp-eyed viewer, you'll notice that the digits we extracted here are both equal to 0. The first digit, palindrome thinks was 0, and the last digit it thinks was 0. But looking at our number, there are no zeros in the number. So right here, we found mysterious behavior that implies we're on the track of what's going wrong. So let's look at how it came up with these incorrect digits. Where did 0 come from when selecting for this number? Well, Palindrome is using the getDigit function to extract those digits, and that function's right up here. In fact, it's about to use getDigit again to extract the next number. In this case, it'd be one of these 2's. We could use the second icon in the console to step into the function that's going to be run in this line. So if we click Next, R will just run this function. If we click Step Into, R will go to that function and run it one line at a time. And that's what I want to do, because now we know that something weird is going on with getDigit. So I step in the getDigit, the highlight goes up here. Now I can step through getDigit one line at a time. I could also look and see what's inside getDigit. So what's the num value here? This tab completion. The num value is 321123. That's good. That means the number that Palindrome is using is correctly passed on to getDigit. What's getDigit going to do with that number? Well, it's trying to find the second value in the number. So let's parse this line of code here. First, it's going to take the number. It's going to do some modulo operation to it. And that's going to return to us, I guess it's looking at the second number from the left. It's going to return it's going to remove everything to the left of that number. So it's going to extract this 2 eventually. I guess that'd be the second number from the right. Let's remove this. Now we just need to remove the 3, and that's what this last component should do. It should remove the 3. But when we run this line of code, we'll probably go get 0 because getDigit's returning 0. So something went wrong there. And if you're familiar with modulo and integer division operations, you might see this. If not, take my word for it. What went wrong is what we want to divide with integer division is the 10th power of n minus 1. So we're looking at the second digit here. So 10 to the second would be the hundreds place. We want to look at 10 to the first and do modulo integer division on that. If we make that simple change, here's what happens. We successfully extract the number 2. This is what went wrong in the function. This is how we've tracked it down and found it. Now that we know which code works, we could put it in here. We could save our file. And we should suspect now that Palindrome might work. But we want to be sure. So first thing I'm going to do is I'm going to exit the debugger mode by clicking stop. My command line goes back to this simple prompt. The environment shows me what's in my global environment. So I know I'm out of the debugger mode. The traceback window disappeared. Now I could run functions as I did before. Since I created a change to this function, I'm going to resource the file so I have the most up-to-date version of the function. Now if I run palindrome 998001, I think it says false. So it seems like things are working. It might be a good idea to try many different cases to make sure that we really have fixed things. So what I'm going to do is I'm going to use another command that comes with R. It's the browse command, or browser command. And the way browser works in R is whenever R is executing a function, it gets to the browser command, it will stop and open the debugger mode. So if I save this and source this file, now maybe I'll run biggest palindrome again. Every time we find a palindrome, palindrome's going to get down here past this if statement, and it'll call browser. And I will open the debugger mode and we'll be able to check and see whether palindrome actually found a palindrome or if it's misfiring again. Okay, so we stop once at browser. We can see in our debugger mode that that's where we're at, browser. And we can look up here in the environment to check out the current number. This number is in fact a palindrome. That L at the end just means it's an integer, or the way it's saved is not exactly numeric. But the number portion of it is in fact a palindrome, so that's good. I want to keep doing this, so I could click the continue button, which we haven't looked at yet. Continue just sends the execution back into motion. The execution will stop if it comes to another browser statement, which it does when it looks at this number, which is a palindrome, so that's another success. And I could keep clicking continue, and I could check until I'm confident that every time palindrome thinks there's a palindrome, it actually is a palindrome. So we've solved this. Now, one problem with using browser when you debug functions is, browser is a piece of code that changes your code. If we exit the debugger mode here, browser is still in our code. If we put this in a package or send it to a user, the code's going to stop and open the debugger mode every time browser's there. So we'll definitely want to remove browser, save our function, and resource it. RStudio has a way that's even simpler than typing in browser into your function. It does the same thing. You could set a breakpoint. What a breakpoint is on the side of your script or function definition, you click in the margin, and RStudio will put a red dot there. It'll also show you in your environments pane that the palindrome function now has a red dot. The red dot is the breakpoint. A breakpoint acts just like a browser statement. So now if we rerun biggest palindrome, we're going to stop right here where that breakpoint was each time. And if we keep clicking continue, we'll have the same behavior we had before. But the benefit of using a breakpoint is it's very easy to turn on and off, and you don't have to change your code to do it. When you're done with the breakpoint, just click it again, and it'll go away. So now that we have this working, source this, make sure nothing's in there, we can find out what is the biggest palindrome. Looking at this, we see it's 906609. Okay, so that's how you could go about debugging your code in R. Those are some of the features that RStudio has. Let's take a look at how you could work with errors when they pop up in R. So here's another piece of code. In this case, Jonathan wrote it. It's designed to take a string of text and reverse the letters in every word in the string. He calls it crazify. So let's demonstrate this. I'll type in a sentence here, command line. When I run crazify on it, one error. Let me source this so I have the actual function. Now when I run crazify on this, we see that we get the sentence back, but the letters in each word have switched. It kind of looks like some mysterious secret language. And in fact, you could use this to develop a secret language, and maybe if no one thinks about it too hard, they won't be able to break your secret. But I don't want crazify to just work on a single string of text. I actually want to be able to apply it, for example, to an entire data frame. So I wrote this, or John wrote this tested function, which creates a simple data frame with 2 sentences, and then I'm trying to apply crazify to that data frame. If I run test it, I'm going to see that this fails. And instead of showing you failing here, I'm actually going to show you how it would fail in R outside of RStudio. So in RStudio, you could go to Tools, Shell, and open up a shell window. This is, the normal environment or the typical environment you might run R in if you don't use RStudio. Go launch R by typing R. So here's R at the command line. And I'm going to source in this file. Let's see if I can remember where I put it. Yep. All right, so now crazify is loaded into this R session, and if I ran test it here, I get an error. And this is what R shows you when you get an error at the command line. It shows you, hey, something went wrong. Here's what went wrong. Well, R is not a very good newspaper reporter. It tells you what went wrong, but it doesn't tell you when it went wrong, how it went wrong. The who, what, when, where, why, and how. You only get what, which means if you're trying to fix that bug, it's going to be a little frustrating. So let's go back to the RStudio IDE and see how we can improve on that. When we run test it here, I get the same error message. But I do get 2 options over here that can help me decipher what happened. The first is show traceback. When I click that, I get what people in other languages would call a call stack. In R, it's called a traceback, and it's just every function that R ran since I clicked enter before it hit the error. So first R called test that, or test it, then it called vapply, then it called some anonymous function, then it called string split at this line 8 here, and we got an error. This is the same output you'd get if you actually physically ran the command traceback after getting an error, so we'll just put it right in there. Traceback is useful. It can show you the when, the where, and the who, what function caused the error. But if you want to get into the why or the how, which is actually what you need to know to fix your error, you'll have to go back into debugger mode and use some of the skills we just learned. Well, it's easy to do that too. If I rerun this command, I get this error. The second option is rerun with debug. If I click rerun with debug, RStudio is just going to rerun that line of code, but when it encounters the error, it's going to immediately open the debugger mode at the place where it encountered the error. So here, our traceback pane here might make some more sense to us. It's the traceback we saw there. These are the functions that are called before it opened debugger mode. We could see, we could click on any of these functions and actually see what happened. So R called test it, and then at this line, test it called vapply. And then vapply is a function that comes in base R. So RStudio opens up a source editor that deparses the vapply function, shows us the code in it so we could see how vapply works. Vapply called an anonymous function. The anonymous function here happened to be crazify, so this would be a little more legible if I didn't call R's vapply function, but this is how you should do things in R. Vapply is going to take the crazify functions, go apply it to census text here. Inside crazify, R ends up calling string split, which causes the error. Now technically the error occurs when R evaluates string split. We can look at that if we want to. So now that we know where this error is occurring, let's see if we can figure out what's going on. The easiest way to go about this might be to just look at the environment and the variables that are at play when crazify is run. Here we can see that crazify is going to try to run string split on structure, str. We can look at when this is evaluated. That'll be better look over here. If we look long enough, we'll notice that structure str is a variable that's a factor with two levels. So string split, if you consult the help page or if you've known it from experience, it's meant to work with characters. And here's the source of our error. And it actually explains why we get this error output, non-character argument. A factor is not a character. And the reason this comes, factors is kind of like the hidden secret of R. R makes so many things factors, character strings especially, by default. And very often that's not what you want. And the way to avoid that is to add the option strings as factors equals false when you do things like make data frames. Now if I do this, if I exit my source, and I rerun test it, we see that test it works. So by getting down to the point where we could look at str and see that's a factor, not a character, it alerted us that somewhere along the way we've created factors instead of characters. That's the source of the error, and then I fixed it. All right, so the last thing I want to look at is how you can use these error techniques with R Markdown documents and Shiny documents. For an R Markdown file, the story is the least compelling. I'll just open a generic R Markdown file. In an R Markdown file, you can include text and code chunks. If you don't know, that's what R Markdown is. It's a way to combine R code with text. And once you make an R Markdown file, I just opened a template file. You can knit it. And well, I guess I have to name. R will turn your file into a finished output. In this case, it's going to make an HTML version of that report that was in the file. It runs the R code and appends the code into your report. One piece of code create this output, another piece of code create this graph here. Now, if you want to debug the code that's in any of these chunks, the best way to do that in R Markdown is just to insert a browser statement. At the moment, breakpoints will not work in an R Markdown file, although you should expect that to change in future versions of RStudio. And then at the moment, there's another aspect, it's actually a feature of R Markdown, that kind of complicates debugging with an R Markdown file. When you render an R Markdown file by clicking knit, RStudio opens a second R process that actually runs all the code in the file. And that's on purpose. You don't want to run code here that might create variables and have the variables appear in your global workspace. Or do you want the code in your Markdown file to rely on variables that are in your global workspace? It wouldn't be reproducible. It wouldn't be isolated from just whatever you'd happen to work on before you made the file. So everything that occurs in our Markdown file occurs in a second R session in the background. But R's debugging features only apply to the main primary R session. So that's why it's a little difficult to debug the chunks that are in your R Markdown document when you render the document. However, you can run any of the R code chunks in your R Markdown file in your primary session just by clicking the play button next to it if you're using one of the preview versions of RStudio, or simply highlighting the code and using the run command. This is happening at my command line, so I could debug this if I had a browser statement there. It'd start browsing right here. So that's our Markdown documents. Something that's probably asked a little more is, how do you debug a Shiny app? Well, we have some tools that can help you do this in the most recent version of Shiny, starting with version 0.12.2.906, well, 9006, so that would be the development version of Shiny. You could get this version of Shiny by using the DevTools package, so download DevTools, then inside that package use the function install GitHub, and then install it from the RStudio/Shiny repository. That will download the development version of Shiny. If you want the regular stable version, just download Shiny from CRAN with install.packages. I have the development version, and I also have this app that Joe Chang wrote. It's a simple example of an app that doesn't work well. There's something wrong with it. When I run the app, it tries to make things work, and eventually encounters an error, and it gives me the error message that R would generate. But over here in the console pane, we have a traceback automatically added to your Shiny app. So somewhere when this app was running, an error occurred, and the traceback shows you what functions were run before that error occurred. It can help you zero in on the source of the error. In this case, we started running the app, and eventually we called this head function, and somewhere after then things went sour. There is a head function in our app, and if you studied it long enough, you notice that head, first argument should be a data set, and the second argument should be a number, so we've gotten things out of sync here. If we switch this around, this app would start to work. You'll notice over here in the traceback that the numbers are not contiguous. It goes from 1 and it jumps to 68. There's a reason for that. Shiny, to work in a reactive fashion the way it does, calls a lot of functions. If you wanted to look at all those functions in your traceback, normally we feel they're probably not going to be interesting, but if you wanted to see them, you could set the options error command shiny full stack trace to true, and then the next time, if I don't fix that, save selected. The next time you get the error, you could look through 100 different functions to try to figure out how you got to that error. By default, shiny full stack trace is false, so you don't need to wade through all that stuff. You could also, in Shiny, add the option shiny.error and set that equal to the browser function. And then what will happen is every time you get an error in a Shiny app, R will immediately pause the app right there and open up the browser mode in your console, which will allow you to explore it. The last thing that you could do with the Shiny app is inside the server function, you could set breakpoints. That will work as browser statements. And this is just like in an R script or a function. When your Shiny app executes and it gets to that breakpoint, it will pause and open up the debugger mode. And from that point on, debugging your Shiny app will be similar to debugging any R function. All right, so that is half an hour exactly. And what we'll do is we'll stick around for 10 minutes to answer questions that haven't been answered, or if you want to submit new questions. But if you don't have time to stick around, which makes complete sense, the debugging documentation is here at this link. I'll make it large. And this is the best place to go to learn more about debugging with RStudio. So thank you very much for tuning in today, and then I'll see you next week where we'll look at making packages with RStudio.
Fantastic. Thanks, Garrett, once again. Another fantastic presentation. As Garrett said, these are designed to be roughly 30 minutes long, so we are at the 11:30 mark, but we're going to hang around and answer some questions. So we're just taking a time check right now. We did that, and now let's get into the questions. There was a couple of questions about the squared parentheses after browse, for example, browse 2, browse 3. Garrett, I don't know if you saw that one.
Oh, yeah. Well, I didn't see the question, but I know what you're talking about. So
the meaning
is
of
it
the
possible
number.
to give me this?
Yep,
Is
absolutely.
it possible to share my screen again? Because I just, for those who didn't ask a question, I want to make sure it's obvious what we're talking about. I want to close some of the stuff going on here. Get rid of this. If I just put a breakpoint in here in palindrome, for example, and then what we're doing earlier, run biggest palindrome, we get a couple things happen. We get a browser statement, and there's a number after this. So you can have debugging environments inside of debugging environments, if that makes sense. So right here, we're inside the palindrome function, if we look at our traceback. And if I wanted to go inside the getDigit function and step into it, you'll notice that the number changes. So now I'm executing inside the getDigit function. Now inside of Git, every time R runs a function, it creates a new environment to run that function in. It's sort of like a sandbox for that function. And that's why we see num and n, they're arguments that are in the getDigit function, but we no longer see the arguments in biggest palindrome, or even the global environment. In fact, in the environments menu, you could use this drop-down menu to look at the different environments that are being called. getDigit's just at the top of the stack. When you see that the number is 3 here, right, the 3 is sort of arbitrary, but the fact that it's different than 2 means that you're actually inside a different environment now than you were back when browser equaled 2. And if I don't know how we do it in getDigit, maybe it'd work with modular or something. We stepped into a different function, it would give us a 4. In this case, it actually just ran that line and put us back in palindrome, so it went back to the 2 environment. So that's just a way to keep track of which environment you're debugging in at the moment, because you can, it's like Inception. You could go many levels deep and then come back out. So hopefully that answered that question. Or is there any other questions, Bill?
Actually, Garrett, you know the link, the debugging link. Can you throw that back on the screen? We should probably send it out as well to everybody. That way, everybody can
Sure.
check it out.
And then, if you don't want to type out this whole link, you could also just go to support.rstudio.com and search for debugging.
Excellent. Let's see. They wanted to copy that link to the chat window. I don't know if you can bang that out real quick.
Uh, what's going on? Yes, I could probably do that. Where is? Okay, there we go.
Fantastic.
Audience send. Okay, so links should be in the chat window there. Now hurry up and copy and paste that because once the webinar closes, you might not have access to it.
All right.
And,
You want to pick a couple more, Garrett?
yes, let me find this questions pane here. Sorry, guys. Wow, there's a lot of questions. The presentation option in the IDE panel, enterprise only. No, that presentation, all you have to do to make a presentation is go to File, New File, our presentation. It's just a new document format. And that works in any version of RStudio. And you can actually, if you go to that support.rstudio.com and search for presentation, there's some documentation that shows you how to do it. It's something we made earlier, and I think right now our Markdown is sort of replacing it, but it does still exist. So please post a link for replay. Well, that's actually a good idea. The link for replay is right here. It's rstudio.com/resources/webinar. This is where all of the webinars are going to end up at. They will be curated into tracks, so you might have to click on the other links from this web page. But this is the RStudio Essentials track, or the Essentials of RStudio.
And they'll also get this as in an email following up from the webinar.
There's some questions about factors. It's just, factors are something that come from the early days of R when R was really focused on building linear models or any sort of model. Factors are an excellent way to model ordinal or categorical data. And so at that time, things were sort of biased towards making factors whenever you had ordinal or categorical data because it saved users time. But since then, people have used R for so many different things that factors really don't have a role to play in all the different ways we use R these days, but that behavior is still in there. So it's always useful to understand that factors look like character strings. And if you look at the environments pane, you could see whether something's actually a factor or a character string. And then any function that makes factors out of character strings will come with the argument strings as factors equals true by default, set to false, and your character strings will save character strings. That applies the most when you're building data frames or importing data. It's just an R thing. When an error occurs in the debugging environment, can I force R to stay inside this environment? Yes, actually, let me show you something that's pretty useful. I meant to mention this earlier, but there's a whole debug drop-down menu inside the RStudio Pro, and one of the options here lets you decide what to do on an error. The error inspector will cause the error to open that gray box next to it where you could click Show Traceback or Rerun with Debug. Message only will just eliminate all that. R will behave just like it does at the command line. You won't have any special sauce there to help you. And then break in code is if you set on error to break in code, whenever an error occurs, R will open the debugger mode. And if the error occurs while you're in the debugger mode, I'm 95% certain that it will just open a new level of the debugger. So your browser will go from 2 to 3, and you'll start debugging the error that just occurred inside browser mode. And this is all in the debug pane here. And if you want help on debugging, there's a link right there inside the IDE which doesn't take you to that specific article I mentioned, but it does take you to a place where you can start poking around and find all sorts of help. I see someone typed in shinyapps.io, but I don't really understand what the question is. Am I on Twitter? Yes, I am on Twitter. My handle is @stat, S-T-A-T, Garrett. Is clicking the red button enough to stop debug? Yes. So the red button when you're debugging here it stops debugging. Continue will also finish debugging by running the rest of the code. Stop just stops where you are and goes back to your regular global environment. How can I take specific numeric input from Shiny put into function? It really doesn't have much to do with debugging, but gosh, it's the command off the top of my head. I don't know if it's stop app or something. There is an app in Shiny. There's a function in Shiny that will return input, and if you look in the articles section of Shiny, you should be able to find something about it. Also, if you Google anything about Shiny gadgets, we're starting to promote that sort of behavior, and we're calling them gadgets, and you'll hear more about that if you pay attention to our blog. Okay, so thank you everyone who stuck around, and thank you for attending the webinar to begin with. Please come back next week and we'll look at other parts of using RStudio. And then if you still have lingering questions, please check out the documentation because we've tried to answer all the questions that people have asked us there.
Fantastic. Once again, thanks, Garrett. Really appreciate the time.
You're very welcome.
Oh, as a note, too, just to let people know, we strongly encourage you to subscribe to our blog at blog.rstudio.org. Also, there's a couple of places on the website. If you subscribe to the webinars, you'll get updates whenever we have a webinar. So that's a good way to stay plugged in for all the presentations. And here are a couple of more places where you can kind of keep in touch with us. And with that, there's all the downloads are on the website, open source and free, as well as the 45-day evaluation of our pro products. You will receive an email, I think within a couple days, that has a link to the webinar, as well as some other information. And we look forward to any feedback. So if you have anything to let us know about, feel free to send us an email. Thanks again, everybody. Appreciate the time.